In this video, I'll be showing you the limits of primitive numeric types and how to convert between them. Rust has many numeric integer types for working with numbers, including 8-bit, 16, 32, 64, and 128-bit integers, and they're both signed and unsigned variants. The isize and usize types are variable size types that are always the size of a pointer. The number of bits will depend on the system that the program is compiled for. For example, a 16-bit machine will have a 16-bit isize and usize type. Rust also includes 32-bit and 64-bit floating point numbers. Here is a chart for unsigned integers showing their minimum and maximum values. The max value for a 128-bit unsigned integer actually doesn't fit on the slide, so it's pretty huge. So if you need to store a really big number, use a U128. Here's a chart for the signed integers. Signed integers can be negative, so you'll use these if you need negative numbers. And again, the 128 is really large. We can annotate numeric literals with their type as a suffix. This makes it easy to determine what kinds of numbers we're working with when you're reading the code. We can also use underscores when we're creating numeric literals. So if we take a look at this third example, we're creating a number that has 999, and we're setting it to be an unsized pointer type. We can put an underscore in between the number and the type. That way it's a little bit easier to read. On the first line, we don't have an underscore, so that could be more difficult, but the underscore makes it very clear. We can also use underscores to separate numbers. So here we have 13,456,000 and 19. That's easy to tell because we have underscores that are separating these groupings. These underscores are completely visual aid only, and they're ignored by the compiler. So feel free to use them to make your numbers and types clear. If we try to set a value to a numeric type, but that value isn't appropriate to fit in that type, you'll get a compiler error. In this example, we're trying to put the value of 300 into an 8-bit integer. The maximum for an 8-bit integer is 255, so this won't work. The error that you get will explain what the situation is, and it says that it's out of range for that data type, and it lets you know what the range actually is. So the range here is 0 through 255. Let's look at numeric conversions. With integers, it's easy to convert between different types. For example, a U8 can always fit into a U16, so conversion is lossless and without issue. However, the opposite is not true. A U16 cannot fit into a U8. If you do perform this conversion, then the resulting value will be restricted to the range of the target type, a U8 in this case. When working with mathematical operations, all operands need to be the same type. If you try working with mismatching numeric types, you will get a compiler error, so there won't be any unexpected results from forgetting to convert to the correct type. If you do need to perform conversions when doing mathematical operations, you should always convert to the largest type necessary to store the largest number needed. This will ensure that you have no data loss, less code, and less chances to introduce bugs. To convert between numeric types, we can use casting using the as keyword. The syntax is simply whatever value you have, followed by the as keyword, and then finally the type that you want to convert into. On this first line, where we start with a 15, that's an 8-bit integer, and we're just going to convert it into a 16-bit integer using the as keyword. On the second line, we have the first value, which is a U8, and we're just ensuring that it is a U8. And then we're going to add a 20 U16, and we're going to convert that to a U8. So as mentioned previously, when you're performing math operations, like adding things together, they all have to be the same type. So if we got rid of this cast right here, we would actually get a compiler error because you can't add a U8 with a U16. If you have more than a handful of values that you're going to be using in a mathematical operation and they need to be converted, it's a good idea to convert them before you do the operations. As you can tell, if you start littering your code with as conversions, then it's going to be hard to see the actual mathematics that you're trying to perform. So if you do them ahead of time, then it gets a lot cleaner. When casting a large number into a data type that has a smaller amount of bits available, there is some math performed behind the scenes. To determine what the result will be manually, you have two options. The first is to take the maximum value plus 1 that can be stored in the target type and subtract it from the original value until it fits into the target type. Here's an example. So we have 600 which does not fit into a U8. So U8, the maximum is 255. So what we'll do is we'll take 600, we'll subtract 256, because remember it's the max plus 1. So 600 minus 256 is 344. That's still too big, so we take 344, we minus 256, and then we end up with 88. Alternatively, the modulus operation will return the resulting value. When casting to a number type that has more storage available, no calculations are performed since the value will fit perfectly into the target type. And all these conversions happen behind the scenes, so you don't actually need to do this math. This is just in case you want to try to calculate the exact value you'll have for your specific scenario. If you are converting from a floating point value to an integer value, some truncation will occur. Floating point values that are outside the range of the target type will be clamped to either the minimum or maximum of the target type, depending on if the floating point value is negative or positive. Here are some examples. In this first example, we're trying to convert 800.5 into an 8-bit integer. The maximum for an 8-bit integer is 255, and since 800 is larger than 255, then the result will be 255. The same applies for the minimums. So the minimum for an unsigned 8-bit integer is 0. Negative is less than 0, so the value will be set to 0 since that's the lowest that a U8 can contain. Here we're using signed values instead. So the max for signed is 127, and the minimum for a signed 8-bit is negative 128. So negative 300 is lower, and so the lowest that it can go is negative 128. If you convert a floating point value that is within the range of the integer type, then it'll just be converted and any decimals will be dropped. There is a standard library function to round floating point numbers, so if you want your number to be rounded instead of truncated, use the rounding function first before converting to another type. One last thing to cover about typecasting, the try from trait is implemented on all numeric primitives, so we can use the try from function to attempt to convert from one type to another. If the value is outside the range of the target type, as is the case here, then we'll just get an error instead of a conversion. This is useful if you want to perform some conversions, but handle special cases where the value does not fit into the target type. To recap, numeric types can be cast using the as keyword. Use the try from trait when you want to be sure that the value will properly fit into the target type. Annotations can be used with numeric literals to specify the type. You can use an underscore as a digit separator, and you can also use an underscore to separate the numeric literal from the type it should be. Finally, it's a compiler error to create a numeric literal that's outside the range of the target type.